Good morning, students. We have studied that when there is energy conversion from low quality energy to high quality energy, then there has to be a certain limit of the in the conversion. Same case is there with the wind. When there is the energy conversion from wind to another form, then there has to be a certain limit. Today, we will try to follow that limit. So, to obtain that, first of all, we will try to find how much power is contained in the wind. Then we will find what percentage of that power can be extracted, means the limit. For that purpose, let us start from power contained in the wind. This is the structure for explanation. To make our explanation easier, the wind is flowing with speed v infinite, and in this wind the energy available is half mv square, that will be in the form of kinetic energy. If we have m as mass flow rate, then it will be power, yes, energy by time. Here we can say m is mass flow rate, m is mass flow rate, and v infinite is the speed of the wind in free space at any point. Okay, so this is the power in the wind. And mass flow rate can be written as density of the air into volume, flow of the volume. Flow of the volume can be written as 8 times V infinite. This is the flow of the volume and it is already given there. So this is mass flow rate and V infinite is square, the formula of the power. Okay, this is the total power that is contained in the wind when it is passing from any cross-sectional area A with speed v infinite. This is the total power contained in the wind. Okay, and here rho is fixed. Rho can be most of the time it will be given to you. If it is not given, then you can assume it 1.225 kilogram per meter per cube meter. Okay, so this is the total power contained in the wind. Now let us try to find if this power strikes with the surface, then like this. Okay, and when this wind flowing from here strikes to this, from where we wish to find the energy conversion, and after striking it moves with speed v, and after that wind at any far away point, its speed will be reduced, obviously, because if it will not reduce, then it will not move. Here the speed will be different from this and this. It may be anything, but not it will be equal to the v infinite. We will see later how it is not possible v infinite. Okay, it means This is the object from where we wish to extract the energy, or we can say power from the wind. And wind is flowing here with speed v infinite. When it strikes to this surface moves with the velocity v, and the speed of the wind at far away point is v infinite. Here the pressure is assumed as P infinite, and at this surface from where power has to be extracted, we can consider pressure before this and after that. We can consider P positive and P negative. Why we are considering pressure, we will see just after few seconds. And at infinite, again we can consider there is equal pressure as it is here. Okay, so once we have this arrangement, then we will try to find how much power we can extract from here. Okay, having this arrangement, now apply Bernoulli's theorem. Now apply Bernoulli's theorem. We have studied in class 12. Pressure here will be equal to the pressure here if it is like that. So according to that, half density into V infinite square plus P infinite. Pressure at this cross section will be equal to the pressure just before of the striking. So pressure will at this point will be half rho V square plus P positive. We can say like that. Okay, consider it equation 1. Now in another region, we can consider the same principle, and on the basis of that we can say half rho V2 square plus pressure, that is almost equal to this P infinite, is equal to the pressure here, half rho V square plus P negative. We can write this, and this is equation number 2. Now for simplification, subtract this. We can do this, and after subtraction, these two will be cancelled out. The remaining term will be half, it is visible, yes, half rho infinite square minus V2 square is equal to pressure difference from the surface where it power has to be extracted. Okay, and if we wish to find the when it strikes to this cross section at A, then how much thrust is applied to that, we will try to find now. Then that thrust we can write is equal to the pressure difference into the cross sectional area, difference into the area of cross section. We can write like this. So on the basis of that, if we want to find the thrust at this cross sectional area A, then we should multiply from A to both the sides. Then we can write half just in continuation of the previous equation, V infinite square minus V2 square, as it was in the previous case, pressure difference from the surface where it has to be extracted. Okay, now multiply from area on both the sides. We can do this. Okay, so this is equation number 3. This is the thrust equation which is applied at cross-sectional area A, from where power has to be extracted. Okay, now come to mechanics we have studied in grade 12. What thrust can be? Thrust also can be written as change in momentum. Change in momentum. And if we know the change in momentum, it means mv2. This will be change in momentum. And m is mass flow rate that we have discussed in the starting. It is from the surface where power has to be extracted, which is having velocity v, and it is v infinite minus v2. This is the thrust we have find out in another way. So if this thrust and this thrust is applied at the same area, at the same body, then these two must be equal. This thrust we can write equation number 4. So equation number 3rd and 4th must be equal. If 3 and 4th must be equal, then we can say this term will be equal to this term. Okay, do it now. It will be equal to the okay, so simple. Just simplify it now. After simplification, these two terms will be cancelled out, and it will be v infinite plus v2 a minus b, a plus b, and a minus b will be cancelled out from here. The remaining will be a plus b. Hope it is clear to all of you. Okay, so in this way we have find out the speed at which wind is striking, which is having cross-sectional area A. Okay, so this is the speed of the body where wind is striking. Now let us have some conclusion from here. We have V2 here, V infinite in the beginning. So on the basis of this, let me draw once again to make it more clear. Here it is V, V2, V infinite. We have this. Consider that V2 is equal to V infinite. If it will be considered as V infinite, then V will be, this velocity will be also V infinite. Okay, what we can conclude from here, if it is also moving with velocity V infinite, okay, it means there will be no power extraction. The power will be extracted only when it is transferred in some form. Okay, So in this case we can say no power can be extracted. Okay. Second thing what we can say, if V2 is 0, no sorry, V is 0, sorry, V2 is 0. If V2 is 0, it means, okay, consider V is 0. It means when air comes to this, it blocks completely. It does not allow to move a little bit. If it is 0, then of course there will be no power extraction. In both the cases, we can say if it is infinite, this power is infinite, then there will be no extraction at all. There will be no energy loss in between from here to here. So if there is no energy drop, then according to conservation of energy principle, no transference at any place between this to this. And second thing, we can say if it stops the full speed of the wind and it does not move at all, it means again there will be no power extraction. Okay. If these two conditions are there, then in that case, between these, in between this and this, there should be some speed of V where power can be maximized. Okay. In both the cases, it is 0. Either V is infinite or V is 0. Both the cases power is 0. But if speed is different than, here speed is different than this, it means somewhere power is extracted. So we will find what will be the condition when power can be extracted from here. So for that purpose, let us define a factor which tells about the relationship between this and this. Okay. So that we can name as axial interference fraction, that factor. By name we can call it axial interference fraction. Name it A. Okay. So let us write a relationship regarding axial interference fraction like this. Okay. We can write and visualize how it is possible, this relationship. Write equation number 5. If A is 0, what it means? V is V infinite. If A is 0, then no power extraction, no power transferred. And if A is 1, then it is 0, V is 0. No power transferred. This situation creates. So from here, we can visualize that this can be related in the terms of axial interference fraction like this. Okay. So in this way, we have written, we can write V and V2 in terms of A. So V is already written in terms of A. Now write V2 in terms of that. So from here, we can relate this to this, and after relating these two, we can write half V infinite plus V2 will be equal to V infinite 1 minus A. Just I am relating these two equations. Okay, if these two are equal, then these two will be equal, and from here we can say, if we simplify, then it will be 2 times v. Okay, I think v2, it will give us v2 as v infinite 1 minus 2a. Just after simple mathematics we can obtain this relationship. Okay, so from here we can transform in v in terms of axial interference fraction, v2 in terms of axial interference fraction. Now if we will follow v and v2 in our power extraction calculation, then the calculation will be very easy. So let us follow that. For that purpose, we can write drop in kinetic energy okay. We can write the power that can be extracted in 1 second. Power that can be extracted in 1 second is drop in kinetic energy. So we can write half kinetic energy. For that, rho a v means the from here this is having velocity v, so we are writing v, and change in speed square. This will be drop in power, or drop in kinetic energy. Drop in kinetic energy we can understand. Kinetic energy here, difference at this point when it is moving with velocity v. Then this term will give us the difference of these two kinetic energies will be here. That will be half rho a v and this. Now put the value of v and v in terms of a to make our power dependent only on the known terms. So following that we can write rho a v, v infinite, v can be written as from the previous one, v infinite 1 minus a, v infinite 1 minus a, and for this we can write v infinite square minus v2 can be written as 1 minus v infinite square 1 minus 2a square. v2 is written this, v can be written this. Okay. Now take v infinite square common from here, then it will be v, and v square it will be v cube. So from here we can write rho a v infinite cube 1 minus a, here it will be 1 minus 4a square plus 4a, just I am doing in my mind, so we can cancel this. Now we will multiply this to this for simplifying the equation. In v infinite cube, after simplification it will be multiplied to this minus 4a square plus 4a plus 4a cube minus 4a square. Okay. Further it can be written as half rho a v infinite cube 4a cube minus 8a square plus 4a. We can write like this. This is the power. If it is mass flow rate, then of course it should be power. Okay. It is mass flow rate, not the mass. If it will be mass, then it will be kinetic energy. If it is mass flow rate, then it will be power. So this is the total power. Hope it is clear. Okay. Now, as our aim is to know when the power, what is the maximum limit that can be extracted from here if it is moving with velocity v. So to get the maximum power, we should get the differentiation of a with differentiation of power with respect to a equal to 0. Okay, at maxima and minima, maximum and minimum point, the rate of change will be 0. So following that, do it and simplify it now. A v infinite cube, it can be outside as it is considered as constant. 12a square minus 16a plus 4. Okay, a should be equal to 0. So the remaining term will be, just I am writing here, remaining term will be 3a square minus 4a plus 1 will be equal to 0. And after factorization, just simplifying this, we can write 3a square minus 3a minus a plus 1 will be equal to 0. From here we will solve, then it will be a minus, it will be 1 by 3. From here it will be a minus 1, so it should be plus 1. Okay, so from here we have two values of a that can satisfy this equation. And if we will put the value of a in this, it means it will give the maximum power as we have done this one. So 1, if we put 1, then in the beginning we came to know that 1 is not possible. At 1 no power is extracted, so we discard 1. The value of this a should be between 0 to 1 for power extraction, and after the differentiation we came to know that it will be maximum at a is equal to 1 by 3. So put the value of 1 by 3 in this equation, in equation number 6. So power maximum will be equal to the half rho a v infinite cube minus 4 a square plus 4 into a, this one, yes, plus 4, we have to put here plus 4 into a plus 4 into a cube minus 4 into a square. Okay, so this is the term. I placed it here. Actually we should simplify this, then we should put it. Anyway, from here we can write, from after putting the value of a is equal to 1 by 3 in this equation, we will find minus 8 by 9, sum of these two, and 4 by 3 here and 4 by 27 here. So this is the final term after putting the value of a is equal to 1 by 3. Now simplify this, 3 by 3, 9 by 3, then 36 plus 4, 24. So 36 plus 4, 40 minus 24, it will give us half rho a v cube, and here it should be 40 minus 24, 16 by 27. So this is the 16 by 27. Now come to the first derivation. What is this? What is this? See here. What is this? This is the total power contained in the wind. From there, this is the total power, this is the fraction of the total power. So in this way, we can say that power, this much fraction of total power can be extracted from the wind. Okay, so if we will do that, then it will be 59 point something percent. Now do it by your own. So this is the we can write this is the 7. So 16 by 27 is the fraction by which wind power, this is the maximum value, power can be extracted. Okay. Now let us consider another case. What is the case? Consider that when wind is striking to this surface, okay, after striking this object starts moving with the velocity v or with another velocity u, and there is no after thrust it starts moving with velocity u. In that case v2 should be equal to 0, and following that we will try to find how much power will be there in this object. Okay, this actually this value is the maximum limit that we can extract. This limit is the maximum value. Now we have to find the different possibilities in which case this maximum value can be achieved, or up to what value of this, what part of this can be achieved in different ways. Among them, the first thing that we have considered, that when wind strikes this, it starts moving with another speed u. In that case, how much power will be extracted from here? Now consider the case that when wind strikes to the surface with speed v infinite, and this object starts moving with speed u, and after that whole energy of the wind is transferred to here. Whole means the energy wind speed v2 that was in the earlier case, it becomes 0 now. Here v is v infinite. So now consider this situation. It means thrust is applied, it is striking to the surface like this directly, and after striking the object is moving. Okay, wind is completely blocked and transferred to the object. In that case, it is called principle of thrust. So let us write it, principle of thrust. So what will be force exerted on it? Will be mass flow rate of the wind, which is moving with velocity v infinite here. Force at any mass flow rate into v infinite. This is mass by time, v by time will be a, so it will be equivalent to ma, mass into acceleration, that will be force. So this is the equivalent of force, we can understand. Now apply a constant factor Cf, force coefficient, apply it. Now consider the case, if the disk recedes with speed u, okay, this is the ideal condition. Now when it strikes to this and disk is recedes with speed u, then what will be force at that case? Force will be CF rho A, change in speed V infinite minus U square. Here V infinite is square, when it recedes with speed U, then change in speed square. Okay. Now we know energy is equal to force into displacement, and if you talk about the power, then force into velocity. Then according to that, if we write to power, then it will be force into velocity of the object. And in continuation we can write CF rho A V infinite minus U square into velocity. Okay. Now we came to know, we have already discussed that U cannot be 0 and U cannot be infinite. In both the cases, the power extraction is not possible. So to get it here, we can simplify this. And for simplification, what we can do, we can divide it with V infinite. In that case, CF rho A 1 minus U V infinite square, then V infinite will be outside, V infinite square, and U divide V infinite again and multiply V infinite again. Just we are remodifying this without any change. V infinite square, V infinite will be taken out common, then it will be square. We have divided. Why we are doing this? After few steps you will understand clearly why we are doing this. Okay, we can write V infinite cube and simply 1 minus U by V infinite square U by V infinite. Okay, additionally what we can do, multiply by half and multiply by 2. Both will be cancelled, there will be no change at all. Okay, now this is the power. Again the condition comes that when it should be maximum. For that purpose, let us simplify. For simplification, to carry on, put U by V infinite is equal to beta. Define another term. So for that purpose, you can write half CF rho A V infinite cube 1 minus beta is square into beta into 2. Okay, this is the power. And to make the power maximum, differentiate it. What is variable here? Beta is variable, that is directly with U. So differentiate it with respect to beta. D power over d beta, it should be equal to 0. And to make it 0, what we can do? Half CF rho A V infinite cube, the differentiation of this, and the differentiation of this will give us 1. Okay, before differentiation, let us simplify this. 1 plus beta square minus 2 beta multiplied with 2 beta. So it will, just I am simplifying this. It will give us 2 beta plus 2 beta cube minus 4 beta. Now differentiate this. It will give us 2 minus 4 beta square. It will give us 2 plus 8 beta square minus 8 beta. Okay, from here we can get just differentiation of beta with respect p with respect to beta. And to make it equal to 0, this term will be equal to 0 because these are constant. So 1 plus 4 beta square minus 4b is equal to 0. And from here I think there is something wrong. No, sorry. It will be 6 beta square. I'm extremely sorry. It should be 6 beta square. 6 beta square. Now everything is okay. When it will be 6 beta square, then taking 2 out, it will be 3 beta square here. Now after simplification, beta will give you either 1 or 1 by 3 after the factorization of the middle term. Now it is not valid again. Beta is equal to 1 only when u is infinite, so it is not possible. Put the beta is equal to 1 by 3. Put it here. Put it here and find the power. Now power will be, put in equation number 7, half CF rho A V infinite cube 1 minus 1 by 3 square into 1 by 3 into 2. Okay, so do it. 2 by 3 square, it will be 4 by 9, 1 by 3, 4 by 27 into 2, 8 by 27. And here half CF rho A V infinite cube. What we can find here? This is the factor by which power can be extracted. Okay, this is the factor. And how it was there in the previous case? This is the maximum possible factor. So this is the maximum possibility for which the power can be extracted, and this is the possible when the speed of the wind becomes 0 at infinite after that, and whole of the energy is transferred to this to move it like this in this speed, to move the disk with speed u. So in this way the transference factor is 8.27. Thus for all thrust operated wind turbine, the ideal efficiency is half of the maximum efficiency. This is the maximum efficiency. So from here we can find this is half of the maximum efficiency. Thus we can conclude one point from here: turbines should not operate that is based on the principle of thrust. So total energy, total wind speed should not strike to this and move it like this. Okay, so there should be another condition when there is some value of the transference lies between these two. This is the maximum, this is the based on the thrust. So all modern turbine does not operate on this principle. Okay, they operate on another principle, and among them that is based on aerodynamic, at which the aeroplane is working. So final concluding statement: the maximum possible efficiency or fraction is this, and the based on the thrust is this. So it is half of the maximum possible efficiency. So this is not opted. An alternate principle should be applied to extract the power from the wind. So for that purpose we are not going to operate this, and alternate operation is based on aerodynamics principle.